In this video, we want to learn Introduction to Astronomical System of Units. Let's look at the learning outcome. Learning outcomes. At the end of this video, you will know what astronomical system of units is all about. You will know astronomical unit of time, astronomical unit of mass, astronomical unit of length, and finally, small angle formula. Let's start with astronomical unit of time. Astronomical unit of time. Before then, we are familiar with the fundamental quantity. And the three fundamental quantity: the mass, the length, and the time. These are the three fundamental quantities with their respective units. The mass is kilogram, the length meter, and the time in seconds. So these are the fundamental quantities that we have, and each of them has its own derived unit. So we use this fundamental quantity in a terrestrial environment. So in space, is it the same fundamental unit that we'll be using? This gives rise to the astronomical, International Astronomical Union. They came about with an astronomical system of units because it was observed that some of the units that we use in terrestrial environment, in space, for instance, because of the distance between two celestial objects, let's say star A and another star B, that will be the distance may be too far, such that if we are to express it using our normal units that we use in a terrestrial environment, like the meter, the kilometer, then we can have value up to this, which may be too cumbersome. So because of this, the International Astronomical Union came up with what we call astronomical system of units. So the focal point of this study is to look at the three fundamental quantities that we have, that we express in our terrestrial environment, having their fundamental unit, their derived units, and to see how we can express them in space. We look at mass, length, and time. Is it the same in space? That is what we want to look at. So let's start with astronomical unit of time. In the fundamental unit, to better understand it, I'll be comparing it with the fundamental unit that we normally have in a terrestrial environment. In the fundamental unit, the unit of time, we have it as seconds, we have it as minutes, we have it as hour. But in astronomical unit of time, time is expressed as day with letter D, and 1 day is equivalent to 6,400 seconds. And this can be gotten, we say that 60 seconds make 1 minute, 60 minutes make 1 hour, 24 hours make 1 day. So if we are saying that astronomical unit of time is expressed in day, and 1 day is equal to this, so if we multiply this by this by this, we will have this. So this is the first unit that we use in the astronomical unit of time. The other unit that we use is year. And the year can be normal year and leap year. For the normal year is 365.25 days, and for the leap year is 366 days. And leap year occurs once in a year. So in astronomical unit of time, we say that we use the unit of day and the unit of year. Let's look at the next one. Astronomical unit of mass. In astronomical unit of mass, normally in our fundamental unit, mass is expressed as kilogram and gram. But in astronomical unit of mass, we use the solar mass. We use the solar mass expressed as this. And one solar mass is equal to 1 times 10 raised to power 30 kilogram. We see how much it is. So in astronomical unit of mass, we express the mass of celestial objects in terms of solar mass, such that one can represent the mass of, let's say, a star to be 2 solar mass. So by this, we are saying that the mass is 2 times this value. So in astronomical unit of mass, you have 1 solar mass, 0.5 solar mass. Through that, we have good representation of the mass of object in space. Let's look at the third one, and that one is length or distance, astronomical unit of distance. Before now, for distance, we use kilometer, we use meter, we have centimeter, derived unit, and other ones. But in astronomical unit of time, unit of distance, all these values, they are not a good representation. So because of that, the distance between the sun and planet Earth was chosen as a reference point. And the distance between the sun and the Earth is 15 million kilometers. And this 15 million kilometers is chosen to be one astronomical unit. So instead of writing all these values, an astronomer thought it wise, just one astronomical unit is equal to this. So if one carried out measurements and you have, let's say, 3 astronomical units, is the same as multiplying 3 by this value. So the essence of the astronomical unit is to see how we have a better representation of the 3 fundamental quantities in space due to the vast distance. And besides using the astronomical unit, which one astronomical unit is equal to 15 million kilometers, astronomers thought it wise that even this may not give a better representative. And we have other units for distance, and one of it is parcel. Parcel is another unit for distance, PC. And beside this, we have other unit called light year. So these are the 3 units that we use in astronomy for distance. We use astronomical unit, we use parcel, we use light year. And there is a relationship, like we have seen, relationship between astronomical unit and kilometer. We have that 1 parcel is equal to 3.09 times 10 raised to power 13 kilometer. And we can also express parcel in terms of light year, and it's giving us 3.26 light year. So these are the conversion factor to convert from kilometer to astronomical unit, and also from parcel to kilometer and parcel to light year. So with this, we have a good representation of a distance in space. The next thing we want to look at is small angle formula. Small angle formula. And what is small angle formula? Small angle formula indicates how the size of an object appears to change with distance. How the size of an object appears to change with distance. And it is given mathematically d to be equal to the angle over 2,06265. We use this expression to find the diameter. So we call this as what? Small angle formula. Let me explain using a diagram. Assuming you have an object here with linear diameter, linear size, d, let's say this is the object, the size of the object d, and you have an observer at a point here, at a distance d. The observer can view the object at an angle phi. So we have said the small angle formula indicates how the size of an object appears to change with distance. So we have an object of diameter d, view at an angle phi, at an angle and at a distance from the object d. So we have an expression that the diameter of the object view is equal to the angle equal to the distance over this given value, meaning the diameter increases as the angle increases. The diameter also increases as the distance increases. A story was told about a child that asked the mom that why is it the aeroplane is very small? So the mom carried the child to airport and he showed the child the aeroplane. He said, that aeroplane that you saw that day, look at the aeroplane here. And the child was wondering, why the difference in size? The mother told her that the distance from an object affects the size of the object, and also the angle at which the object is viewed. So in viewing a plane, one has to look up at a given angle. So we call this equation small angle formula, and it gives us information about the size of object in relation to the angle that the object is being viewed, and also to the distance from the observer to the object. So we call that small angle formula. The unit of the distance here, the linear distance, is in kilometer. The distance here too is in kilometer. Then the angle, normally, angle is measured in degrees. Angle is normally measured in degrees. Angle is also measured in other units. Angle is also measured in arc seconds. In arc seconds and arc minutes. And there is a relationship. We have that 1 degree is equal to 60 arc seconds. Degree is represented arc seconds, then arc minute. So 1 degree is equal to 60 arc minutes. 1 arc minute is equal to 60 arc seconds. By that, we can have that 1 degree is equal to 3,600 arc seconds, 60 by 60. So we use this. Like we say, the angle at which an object is viewed. For smaller angle, we use arc minute, arc seconds, but for a larger one, we use degree, and this is the conversion factor from degree to arc minute to arc seconds, degree to arc seconds. Lastly, let's solve an example. We have a question here. On August 2013, mass was 943 million kilometers from Earth and had an angular diameter of 31.2 arc seconds. Using the small angle formula, determine mass actual diameter. So the question is straightforward. We are to find the diameter d, and we know our formula that is equal to angular size, the distance 206,265. The angular size is given 31.2 times the distance is given 943 10 raised to power 6 kilometer. Then 6265. So if we simplify this, we have 1.43 times 10 raised to power 5 kilometer. So this is the angular diameter observed. Thank you very much for your listening. Please like and share this video. Bye for now.